Here I have an object with me, and if I place the object here on the surface, I see that the object does not move. Well, we know that gravitational force is acting on this object, right? So gravity wants to pull the object downwards. So gravitational force is a force that acts in the downwards direction. From Newton's first law and also the second law, we know that an unbalanced external force will cause an acceleration to any object. So why isn't this object accelerating? Well, this clearly means that because this object is not accelerating, it means that the object is being acted by some balanced forces. So the first force that is acting on this is the gravitational force, which is in the downwards direction. So what is it, which force is it that is countering the gravitational force, or which is acting in this direction, and which is balancing the gravitational force, and due to which the object is under balanced forces and is thus not accelerating? Well, that force is called the normal force. So if we see, when I place it on the surface, this pen holder exerts a force on the railing or the surface here. On the surface here, it exerts some force. That force is due to gravity. Okay, so that force is acting downwards and it acts on this surface. But by Newton's third law, we know that because this object is exerting some force on the surface, by Newton's third law we know that the surface must exert an equal and opposite force on the object. So therefore the object exerts some force on the surface, which is due to its weight, and the surface exerts an equal and opposite force in this direction onto this object, and due to that the object is under balanced forces, because that force which the surface exerts on this object, that force cancels the force of gravity. So the force that acts upwards and is exerted by this surface onto this object is called the normal force, and this normal force is in the upwards direction. So it's opposite to the gravitational force and is equal in magnitude to the force of gravity, and that's why it cancels the gravitational force, and the object is under balanced forces and thus does not accelerate. Now if let's say this object is moving with a constant, so let's for some moment neglect friction. Let's say this surface has no friction on top of it, and now if I give it a slight push, so the object will obviously keep on moving, right, because there is no friction, so there is no external force to stop it. So it will obviously keep on sliding in this direction. Now if we see that this thing is moving with a constant speed and the force of gravity is acting in the downwards direction, so even in this case, because gravity is acting in the downwards direction and gravity is being balanced by the normal force, therefore gravity is not causing any acceleration in the horizontal direction, in the vertical direction actually, and the object is moving in the horizontal direction with the constant velocity. So in such a case, when the force, which in this case is a gravitational force, is perpendicular or is at 90 degrees to the motion of the object, even in these cases we say that no work is being done, or the work done is zero, because the force acting is perpendicular to the motion, and the force which is gravity in this case has no contribution in this motion. So this motion was due to the slight push that I had given. So only I had done some work on the object initially, but after that when it moves with a constant velocity, gravity does not affect its horizontal motion because it is acting in the vertical direction, and therefore in any case when the force is perpendicular or is at 90 degrees to the motion, we say that no work is being done, although there is some force and there is some displacement, yet because the displacement is not being caused by the force, because the force is acting in a different direction altogether, and because the direction of the force is perpendicular to the direction of motion, we say that no work is being done. So that is the third case in which the work can be zero. So firstly, the work done can be zero when the force is zero, or when the displacement is zero, or when both of them are present there, but both of them act in perpendicular to each other. For example, the case that I showed you right now. So that is the third example where work can be 0.